Welcome back, Grade 7 Python programmers. Today, we are diving into our explainer for the exact lesson titled Input and Output, Mini Project Video Overview. And just for your notes, the official lesson ID is STEM Python, Unit 06, Lesson Pack 04, Input and Output, Mini Project Video Overview. We're going to master exactly how data enters our Python programs and, honestly, how to make it look absolutely awesome when it leaves. So let's get right into it. Okay, so let's kick things off by confronting a massive misconception. If you type the number 42 into a Python prompt, does Python actually see a math number? A lot of us just kind of assume that when a user types a number on their keyboard, Python magically knows it's a number and boom, it's ready for math equations. But is that actually true? Well, we're going to look at the official documentation in a second to find out. And hey, while we're at it, here's a second question for you. Are we literally stuck with basic, boring, unformatted text every single time we want to show our results? Because, so often we write this brilliant program, we do some heavy background calculations, and then our final output is just this messy jumble of words and decimals crammed on the screen. Do we really have to settle for plain old text when we use the print function? Well, let's check the official Python documentation for the evidence, starting with that first myth about input. According to the built-in functions docs, when you use the input function, Python, and I'm quoting literally right from the text here, reads a line from input, converts it to a string. Notice what's missing there. It doesn't say a single thing about math numbers. It clearly states that the input function always converts whatever you type into a text string. So even if you hit the digits 4 and 2, Python just captures those keystrokes and hands you back plain text. And this right here perfectly illustrates why understanding that difference is absolutely crucial. Think about the string 42 with quotation marks around it. That is purely text. You definitely can't safely multiply or divide with text. But then look at the integer 42, no quotes. That's an actual usable mathematical number. The input function is only giving us that raw text string. But if we're, say, building a calculator, we desperately need that integer to do our math. So, how do we actually bridge that gap? Well, the documentation gives us a lifeline, the built-in int function. The docs define int as a function that returns an integer object constructed from a number or a string. Basically, if we feed it a text string that happens to look like a number, like our text 42 from the user, it strips away those text properties, converts it, and gives us back a real, usable math number for our equations. It's exactly what we need. Okay, so what about that second myth? Are we doomed to boring print statements? No way. Busting that myth wide open, the docs introduce a section literally called Fancier Output Formatting, highlighting formatted string literals. We just call them F-strings. And they are super simple to use. You just slap a lowercase f or capital F right at the beginning of your string, and then you can write Python expressions directly inside curly braces. This means you can inject your variables right into your text to build beautiful, dynamic output. No more messy plus signs or string concatenations. It's a real game changer. So the big question is, how do we combine all these cool concepts? We're going to build a mini project where we ask a user for a number and calculate its square. And we'll do it in 3 simple steps. Step 1, get the string with the input function. Step 2, convert that string to a number with the int function. And step 3, format our final answer beautifully with f-strings. Let's walk through this worked example together right now. Starting with step 1, we set up our code just like this. We say user_input equals input, and then inside the parentheses we pass it our prompt. Enter a number to square. When we use the input function with a prompt like that, it actually pauses the program. The screen displays the message and just waits for the user to type something. And whatever keys they press, boom, captured strictly as a text string and safely stored in our user_input variable. Moving right along to step 2, let's see how this builds. We've got our text, sure, but we need to do math to find the square. So we take that text string variable and wrap it inside the int function. That converts it into a numeric integer, and we assign that result to a brand new variable called num. Now, num holds a true mathematical integer, and Python is officially ready to calculate. And finally, for step 3, we use an f-string inside our print function to get a perfectly formatted result. Look at how clean that line of code is. Because we put that little f right before the opening quote, Python knows to peek inside those curly braces. For the first set, it just pulls the value of num. But for the second set of braces, amazingly, it evaluates the math expression, num times num, right there on the spot. It does the math and places the answer directly into the flow of the sentence. Okay, now it's time to level up with a transfer task. Think about how we can stretch what we just learned to handle totally new formatting requirements. Like, what if we're generating a visual report and we want our output numbers to be padded with leading zeros so they look like an ID number? Or, what if we have a whole list of results and we need them to line up neatly in vertical columns? How do we handle that? Well, if you ever need leading zeros, the Python documentation points us to the zfill method. Basically, zfill takes a numeric string and automatically pads the left side with zeros until it reaches a specific width. So if you've got the string 12 and you use zfill with a 5 in the parentheses, Python instantly slaps 3 zeros on the front, giving you 00012. It even understands positive and negative signs, which makes it a super fast way to standardize your string lengths. But check out how that string zero padding compares to what we can do straight inside an F string. Instead of using zfill, we can use a colon followed by an integer, like the 10 in our phone example, right inside the F string curly braces. This sets a minimum character width. The documentation specifically points out that this is incredibly useful for making columns line up because it forces the output into a specific width block. Everything aligns beautifully on the screen, and you don't have to manually count out spaces. And that brings us to the ultimate takeaway for today's explainer. You are in total control of your programs. You know exactly how to safely convert raw user text from the input function into usable mathematical data using the int function. Plus, you know how to format it beautifully on the way out using F strings and width specifiers. So, I'm leaving you with a challenge. Are you going to let Python push you around with messy, crashing text strings? Or are you going to use your new powers to make your next grade 7 mini project completely unbreakable and visually spectacular? Keep coding, have fun formatting, and I'll see you in the next explainer.